All right, so let's take a look at this circle that we have drawn here. And we're going to call this our unit circle. Okay. So for the unit circle, we're looking at having a radius of 1. Okay, so that's the big idea for the unit circle. The radius is equal to 1. So the way this breaks down, we want to measure and find the nice values for degrees and our radians. So that's going to be 0 degrees, 0 radians, up here at the top, 90 degrees, which is pi over 2. And then over here on the far left, 180 degrees, which is not 2 pi. Yeah, slow down here. And that's going to give me pi. And then from here, we just kind of break things down the rest of the way. Now, I do have some extra lines in here I'm not going to be focusing on. So the nice, easy guy to see is this one right here. And so this is when you are at 45 degrees, which corresponds to a radian value of pi over 4. And I mentioned in the previous video that anything that is something pi over 4 is going to have a 45-degree reference angle. So if you were to come out over here, try that again, over here to this guy, this would be at 135 degrees, and this is going to be 3 pi over 4. I know it may be difficult to kind of wrap your mind around these fractions, but think about it this way. From 0 all the way over here is 1 pi, and we're just divvying this up. So you have half of this is pi over 2, so half of 180 is 90. Half of that, again, is pi over 4, and half of 90 is 45. And then it's just a matter of playing around with the fractions to get this guy over here. And then we have reference angles that are going to be 30 degrees. And that matches up with this one here and this one right here. So this would be 30 degrees, which has radian measure of pi over 6. And this is going to be 150 degrees. And this is 5 pi over 6. So again, if you can imagine that you are breaking things down in terms of sixths, you have 1 here, 2, 3, 4, and there's 5, and then over here is 6 out of 6, which is just 1. Now, even though it says 150 degrees for 5 pi over 6, the reference angle right here would only be 30 degrees. And that's very important because even though I'm going to show you the values for all the pieces that are here, you really only need to learn what's in the first quadrant. Because if you know the first quadrant and you know how to manipulate your signs, you have everything else. All right, and then we have those 60-degree angles. So we got this one, and then we have that one. All right, so this would be 60 degrees or pi over 3. And this one is 120 degrees or 2 pi over 3. So again, anything that is going to be something pi divided by 3 will have a reference angle of 60 degrees. So if you were to measure this, that'd be 60 degrees. For the stuff that I haven't read, that's something pi divided by 4. That's going to have a reference angle of 45. So this would be 45 degrees right there. And you might be wondering, how come I'm not messing with this other dashed line right there? Well, because that's going to be 15 degrees. We could look at that and we could say, oh, well, that's going to give me, pi over 12. But the problem is the coordinates that we would have here on the ends for these points would not be nice. They're really quite ugly for that. But these endpoints are fairly nice. Now let's look down here at the bottom ones, make sure we complete the rest of this. So here is another reference angle for 45 degrees, and this one as well. And so this is going to be 225 degrees or 5 pi over 4. So when we're in quadrants 3 and 4, and you start thinking about these in mixed numbers, when I go all the way over here, that's 1 whole pi, and I'm doing another quarter pi, so 1 1/4 is 5/4 Then you have 6 pi over 4 would be another 45 degrees, but that's going to be a special guy. But this other one over here has a reference angle of 45, and this is at 315 degrees, or 7 pi over 4. So when you get all the way back up here, you're at 360 degrees, or 2 pi. So you can think about 2 full pi less a quarter. So it's like $2 less a quarter would be $1.75, so 1 3/4, or 7/4. Again, the more you work with these, the easier it is to know where you are, what the reference angle is, and how it all connects. So then here are the blue guys for our reference angles that are 30 degrees. So this would be 210 degrees, which is 7 pi over 6, and 330 degrees, which is 11 pi over 6. Again, 1/6 of a pi shy of being the full 2 pi. And then finally we have these guys here. And that corresponds to, slide this down a little bit, 240 degrees, which is going to give me 4 pi over 3. And this one will be 300 degrees, or 5 pi over 3. And the one where we are going straight down is 270 degrees, which is 3 pi over 2. Okay, so now that we have that, we want to talk about what the coordinates are for these points. And again, I said that if we can focus on this first quadrant right here, if we know everything that's in this first quadrant, then we have everything else. So let's get to that. All right, so down below we have our first quadrant. Okay, so let's make sure that we remember the nice key values that we were talking about. So we have our 45 degrees, and then we have 30 degrees and 60 degrees. And what we want to do is we want to look at what the coordinates are for each of these points. Now, starting here is pretty simple. This guy is the order pair 1, 0. And then up here, when you're at pi over 2, this is going to be the order pair 0, 1. So let me just kind of write these guys right here. So this is going to be 0. This is pi over 2. This guy is pi over 4, pi over 6, and pi over 3. Here's an easy way to build these order pairs. Okay. So I'm at 0. I'm going to write 1, 2, 3. The square root of 1 is 1. You're going to put this over 2. You do the square root of 2 divided by 2, the square root of 3 divided by 2. So those will be, or that will be the pattern for your x coordinates. Your y coordinates are going to look very similar to that. So 0, 1, 2, 3. The square root of 1 is 1. Put it over 2. The square root of 2 divided by 2. The square root of 3 divided by 2. So we have these key values. And since our radius here is going to be 1, earlier when we were talking about how sine is y over r, when we're on the unit circle, that means that our sine value is just going to be the y when you're on the unit circle. Similarly, for cosine, we said that cosine, we define this to be x over r, but that means that cosine is just going to be the x value when, again, we're on the unit circle. So if we can memorize these values, it's going to be pretty simple. And if we have to figure out where we are in a different quadrant, that's fine, because we know from up here, we have how the colors all work. So if you know what the coordinates are, when you have a reference angle of 45 degrees, it's going to work for this guy. It's going to work for the other two on here as well. It's just a matter of picking the right signs. Okay, so let's actually make a little chart for that. So we've got the picture here, so keep that in mind. And we're going to do a little chart that has our theta. And we're going to write what sine is versus cosine, and then tangent. All right, so the angle measures that we care about, let's do 0 degrees, which is also 0. We'll do 30 degrees, which is pi over 6. Again, you want to make sure that you know the connection between the degrees and radians. 45 degrees, which is pi over 4. 60 degrees, pi over 3. 90 degrees, which is pi over 2. All right. So the sine values, actually let's go straight across here. So when you're at 0 degrees, sine of 0, and like I said before, sine is going to be your y, sine is 0. Your cosine is your x, so that's 1. Tangent, if you remember the way that tangent is built, you remember the quotient identity, that tangent is sine divided by cosine. So if I do sine divided by cosine, 0 divided by 1 is 0. I'm going to go to 30 degrees. That's when the sine value was 1/2, and cosine was the square root of 3 over 2. When you do the ratio of sine to cosine, and you rationalize that denominator, you end up with the square root of 3 over 3. Now, 45 degrees is actually one of the best ones here because you see that both x and y have the same coordinates. So we're going to say the square root of 2 over 2 for both the sine and cosine. And if I do the quotient of sine over cosine, since they're exactly the same, the tangent of 45 degrees, or the tangent of pi over 4, is 1. But also remember the trick that I was telling you about how we come up with these values. Like for sine, for the y value goes 0, 1 over 2, square root of 2 over 2, square root of 3 over 2. And here, if I'd done a 4 and I did the square root of 4 divided by 2, that's just 2 over 2, which gives me the 1. So that's kind of where the pattern comes from, or how it continues on. So 1, 2, square root of 3 over 2. And then if you went to, again, square root of 4 over 2, that just gives us 1. And we know that at 90 degrees, we're facing straight up due north, and the y value there is going to be 1. Look at the cosine, though. It goes from 3 to 2 to 1 to 0. Now for tangent. Sine over cosine here at 60 degrees, or pi over 3, gives us the square root of 3. But when I try to do sine over cosine when it's 1 and 0, tangent will be undefined. Now, if we start bringing in the other trigonometric functions, so let's do cosecant, secant, and cotangent, and see how these guys fare. So with cosecant, it's supposed to be the reciprocal of sine. So if sine is 0, that reciprocal, well, that's going to be undefined because you have 1 over 0, and we can't divide by 0. The reciprocal of 1/2 is 2. The reciprocal of the square root of 2 over 2 is the square root of 2. The reciprocal of this one is going to be 2 square roots of 3 divided by 3. And the reciprocal of 1 is 1. Now, secant is going to look very similar to cosecant, except it's going to be going backwards because these guys are going backwards from those. So let's do it backwards. So this is going to be undefined at 90 degrees. It's going to be 2 here, which again is the reciprocal of 1/2. That's the square root of 2. And then we have, well, that's messy, 2 square roots of 3 over 3, and then we have 1. Cotangent is the reciprocal of tangent. So if I do 1 over 0, this guy is going to be undefined. If I do the reciprocal of that, I end up with the square root of 3 when I simplify. Reciprocal of 1 is 1. Then we have the square root of 3 over 3. And then you can't really do the reciprocal of undefined. But notice how these values for cotangent are going in a backwards order than they are for tangent. And at 90 degrees, it's going to end up being 0. So where tangent was sine divided by cosine, 1 divided by 0 is undefined. Cotangent is going to be cosine divided by sine. So 0 divided by 1 is 0. So these are the values that we need to make sure that we absolutely 100% know. Okay? Especially these guys here, here, and here. Because if you know sine and cosine, you can build that to get tangent. And then from those, knowing the reciprocal identities, you can get cosecant, secant, and cotangent without any problems at all.